Hi, and welcome to the Control Engineering webcast, How AI-Based Asset Performance Management Fast-Tracks Manufacturing Operations, sponsored by Identex. I'm your moderator, Gary Cohen. Happy to join you today on behalf of Control Engineering. So let's start by talking about some tips to help you get the most from today's webcast. If you are experiencing issues with your slides or audio, please refresh your browser or click the Refresh Media button directly under the presenter's picture. You can control the volume of this webcast by adjusting the volume on your computer or by adjusting the volume on the webcast platform. If you're having technical problems with audio or the slide presentation, just click on the question mark at the top right corner of your screen to access a list of system checks to try before contacting an online technician. But if you do need a technician, just type a message into that Ask a Question box and someone will get to you as quickly as possible. You can also type questions for our speakers in that same Ask a Question box on the left-hand side of your screen. The live Q&A session will begin after the presentation concludes. Today's webcast is being recorded, and you'll receive an email within a week with the link to the on-demand event. To download a certificate of completion and a PDF copy of the presentation, just use the Event Resources tab on the left side of your screen. Those documents will also be available with the on-demand version of the webcast. I'm happy to introduce today's presenters, Stuart Chalmers and Joe Lee. For more than 25 years, Joe has served in a number of senior marketing and product management roles. Currently, Joe serves as the Global Product Marketing Director for Identex, where he spearheads the deployment of the company's AI, edge, and cloud-based solutions for semiconductor, pharmaceutical, automotive, test, and assembly smart manufacturing. At Identex, he works with customers and their engineering groups to integrate industry-leading engineering and automation, process control solutions. This includes the latest AI-based fault detection, root cause analysis, and predictive analytics solutions that improve product quality and guard against events that harm yield. Prior to joining Identex, he served in senior product management and solutions architect roles for Rockwell Automation and Belden. Stuart Chalmers is the Chief Business Officer at Identex. He leads business development, business strategy, and marketing activities, helping to support the smart manufacturing strategies of high technology and industrial manufacturers and OEMs in the USA and around the world. Stuart is a member of the leadership team at Identex, helping to define the long-term corporate and strategic growth plans. He's an experienced executive who, for the past 25 years, has grown public and privately held manufacturing and technology firms, helping them to successfully bring new products and technologies to the market. For the past 5 years, he's focused his energies on bringing to market new digital technologies, including exciting new IIoT and AI-driven products like Grandview Asset Performance Management, which is helping businesses achieve true digital transformation. Thank you so much today for joining us, gentlemen. And Stuart, now the fun part. I'll hand it over to you.
Great. Thanks, Gary, and welcome everybody to the webcast. Before we get going and get into some of the exciting content we have for you today, let me spend a minute or two just introducing you to the company. So Identex is a manufacturing analytics company that helps industrial and high-tech manufacturers avoid any unscheduled downtime. In other words, we like to keep the assets healthy and operating at their peak performance. That's our mission in life. Our goal is to empower engineers with the tools that they need to achieve that goal. We're not new to the manufacturing sector. We've been in the manufacturing space for the last 21 years in one form or another. Initially, for about 20 years as Bistel and Bistelligence, we operated in what I think some would consider the most complex and highly automated manufacturing environments that are out there. And over the last 4 or 5 years, we have taken those learnings and we have built a new Grandview Asset Performance Management framework and a company that's exclusively focused on the industrial manufacturing sector, coming at a time when smart manufacturing and digital transformation is moving full speed ahead as companies recognize the value and the data that exists in these plants. So the problem that we're trying to solve today is something that we've been familiar with for quite some time. I think now with data, with the spread of data across the factory, with the value that people are recognizing within that data, There's an opportunity now to solve maybe a couple of the big headaches that have been challenging us as manufacturers for the past several decades. The Grandview asset performance management solutions that we put in place really address unscheduled downtime. As you can see from the slide here, the most recent estimates put the losses in almost $1 trillion annually for manufacturers. That's about 3.5 million man hours every year, not to be sneezed at. And then the impact of any production downtime event is, can be catastrophic, both in terms of dollars and disruption to the entire plant and manufacturing process. So what we're trying to do today is to solve some of those problems with our manufacturing AI analytics framework called Grandview, which we launched just last year. If I dial down a little bit and go into some, an example of one of the problems that's probably quite prevalent today, it's in the area of maintenance. We know right now that maintenance is a very costly line item on the budget, and for the past several decades, a lot of manufacturers have been operating at run to failure, time-based, and now condition-based monitoring. Sadly, that still pretty much predominates today, although in the last couple of years, it's starting to pick up. In semiconductors, we've been in a very automated environment for quite some time. And industrial, they're making a move toward more predictive maintenance approaches because of the value and the costs and the savings that one can realize. For us, the holy grail is prescriptive and autonomous knowledge-based environment that allows the solutions like Grandview to focus on tasks and puts the engineers in a decision-making mode where they can do the analysis and make high-value decisions for improving their asset and their plant. Not just to listen to us, but taking a look at the data out there in the marketplace right now, you'll see that in high tech, which for us is semiconductors, it's a pretty automated, pretty complex environment, and we're about 80 to 90% adoption rate in terms of these new asset performance or digital transformation type solutions. Some of these other sectors like energy, industrial manufacturing, chemicals, and so on are starting to adopt at a faster rate. And so that really confirms to us that the market is moving quite aggressively. The recognition that there's significant value in the data, and investments are taking place, particularly in chemicals and pharmaceutical manufacturing, who are moving ahead quite rapidly in the last couple of years in terms of digitizing their plants. Some of the big drivers for us as we talk to customers in the field include, the ability to maximize the asset utilization. In other words, extend the life of your asset, get more out of it through AI analytics. Reducing downtime, like we talked about, is one of the main problems. And then cutting, overall business costs and improving productivity and profitability can come with that digital transformation. And the market also bears that out. As you see today, $60 billion market. Within about 7 or 8 years, we're looking at a $250 billion asset performance management market. And that's just one subsegment of the overall Industry 4.0 or digital transformation space. One of the solution that I talked about that we've spent the last 4 years developing and launching in the marketplace focused exclusively on reducing downtime and eliminating any bottlenecks in the process is the Grandview Asset Performance Management Framework. It's no good to come in and try to, throw out the baby with the bathwater and invest in new solutions like this. You've got to be able to integrate with legacy systems. And so the beauty of the Grandview framework that Joe will talk about in a few use cases shortly really is the ability to integrate with legacy systems. It's a very scalable solution that connects to any data source, is completely interoperable with most systems out there, and offers unique, basically a closed loop system for monitoring and detecting any degradation in performance and for estimating and predicting any possible downtime events. And it goes further than that by being able to connect to your maintenance management systems of your plan you basically create this closed loop, fully integrated system. So we're very excited about that. We've seen some adoption in the industrial space over the last year and a half for our solution and other solutions. We believe this is a very, very easy to integrate, scalable solution for any manufacturer, large and small. So I'm going to introduce Joe Lee at this point, and Joe will talk about the impact of asset failure, talk a little bit about Grandview asset performance management, and then talk about some of the use cases that we've experienced in the last year and a half to 2 years with the Grandview. Joe?
Thank you, Stu. Okay, let me move on to this slide right here. To start, I just want to quickly give a couple of examples on what real-life impact we are talking about here when a piece of critical factory asset fails. In this first example, we have a water purification system. In many industries, pharmaceutical, semiconductor, food and bev, purified water is a main ingredient in the manufacturing process. This particular system takes city water, if you go from the left to the right, takes city water and purifies the water to be used in production. Basically, the output on the right side there. There are two critical assets in the system. The RO pump that moves the city water through the reverse osmosis process, therefore called the RO pump, and the DI pump on the right that is responsible for moving the water through the deionization process. In this case, as I learned from the customers, if either of those pumps go down, the replacement event could result in a minimum of 4 to 6 hours of downtime. Obviously, that directly impacts production. In this second example, we look at some overlooked critical assets in manufacturing, and they are the factory support tools. We tend to focus a lot more on the process tool, but there's a bunch of factory support tools that are as critical as the process tool. Examples of these tools would be chillers, scrubbers, vacuum pumps, and in this example, vacuum pumps is what we are highlighting here. Vacuum pumps are very common in manufacturing, particularly in, again, pharma, chemical, food and bev, and semiconductor. In this picture shown here, a bank of these vacuum pumps are supplying process equipment the necessary air pressure. And depending on the size of the facility, there could be hundreds of these, up to thousands of these. So particularly in semiconductor manufacturing where batch processing is common, if these pumps fail, and we just happen to be in the middle of a batch process, the entire batch have to be scrapped. And depending on what product you're producing at the time, the impact could be hundreds of thousands of dollars or higher. And this doesn't account, for the time that it takes to replace the pumps and the time to reset the system, etc. So, as Stu had mentioned before, to prevent unexpected downtime, many manufacturers are beginning to adopt asset performance management systems, or APM, as we call it throughout the presentation, systems in monitoring their critical assets. And in the next section, I'll give a quick introduction on what goes into an APM system, and then at the end, I'll sum it all up with some use cases. So asset performance systems or solutions, or APM system or solutions, are software systems designed to maintain the health of your critical assets. So health of these assets is the focus of an APM solution. This allows you to, when you implement an APM system, it allows you to maximize the life of your assets, eliminate unexpected downtime due to equipment failures. There are three aspects of health that an APM solutions focuses on. First, if you look at the left side here, it is the real-time assessment of health. This allows you to know exactly how your assets are performing at any given time. So that is the asset health assessment component. In the middle, what you see is the detection and the diagnosis of health issue. This is so you can remedy or correct any issue early and quickly. And then to the right, last but not least, it is the health maintenance support. It is to help you stay on top of keeping your assets healthy and operational. Basically, from left to right, you have monitor, detect, and maintain. Here's what an APM system looks like at a high level. There are four components to it. The system basically pulls sensor data from your machines or your critical assets, analyze them to give you their health status, look for issues, or predict impending failure. And you can see on this slide, the four components are in the bottom here, data connectivity. On top, you have AI analytics. And in a modern APM system, the enabling technologies for detection and analytics are typically AI-driven. So that's why I have AI analytics here. On the left, you have global visibility. And then on the right, we have what we call workflow automation, which Stu had mentioned a little bit about. I'll touch on each of these in the next slides. Obviously, the key to monitoring anything is the data. Without the data, there's nothing to really analyze. In a manufacturing environment, there are many, many sources of data that that data can come from. This may include the PLC. The information may come from the equipment or the asset themselves. It could be from a database like a historian database, or directly from a smart sensor or an IIoT sensor. Whatever the source may be, an APM system can connect and centralize these data using various protocols, regardless of the infrastructure. That is the beauty of the whole IoT infrastructure. And once the data is collected from these sources, and since they are likely in different formats, pre-processing of the data will have to be done. So that the APM software, in this case, Grandview APM, can collectively analyze the information. One important thing to keep in mind, though, is that the process of collecting the data, pre-processing the data, and analyzing the data, all that is done simultaneously and in real time, so analytic insights can be provided as quickly and as instantly as possible. Once the system has the data, analytics takes place. And before we go into what kind of functionality the analytics have, I would like to introduce a quick concept that is used in our Grandview APM platform. Factory assets, as I mentioned before, come in different shapes, sizes, complexity. Some assets can be easily monitored using just a single vibration sensor. But for a more complex asset, like say a multi-stage vacuum pump, for example, you may have to monitor many parameters together in order to track the health status or the status of the overall system. In our APM solution, there's a concept called an asset health index, or asset health score. You can think of an asset health index as a number that represents the summary of all parameters related to that individual asset. And in our solution, this index or this score is calculated using AI algorithm, and it provides a simple way for someone to reference the current health of that asset, right? So instead of having to look at 15 different parameters to try to figure out whether the asset is performing as expected, you have a one number reference that can simply tell you the status of its health. And this health asset is automatically calculated in real time based on its historical performance, based on its current status and projected performance. So this asset health index is a true reflection of the health of that specific asset. And in this slide, the table you see on this slide is showing an assortment of factory assets and their related health score. And I will mention this asset health score or asset health index in many of the upcoming slides. So as we mentioned earlier, one of the key functionalities of an APM solution is its ability to do real-time monitoring and fault detection. In an APM system, like other fault detection system that many of you have used, engineers can manually set up control limits around a piece of streaming data. And when the data value goes above or below the control limits, an alarm is triggered. This is particularly common when, say, an engineer has domain expertise on the asset or the system. But with an AI-driven APM solution like Grandview, an engineer now has the option of either setting up the control limits manually, as he has done before, or have the APM system create the fault detection model using AI or machine learning based on historical data. So basically, you can provide historical data for the APM system to analyze and have it intelligently set up the model for detection. One thing to keep in mind before I forget is that the limits, these models, these detection models, are set for not only the asset health index, which is what I mentioned earlier, but for all the individual parameters as well. So the engineers can get alarm notification based on basically anything that goes wrong in the system, whether it is one individual piece of parameter or the overall asset health index on the asset itself. Beyond the traditional fault detection, predictive analysis is another key feature in an APM solution. With this functionality, the APM system monitors and tracks the asset health index and then uses AI to build a prediction model. You can probably see that in this slide here, to estimate the remaining useful life of that asset. And remaining useful life on the slide is referred to as RUL. And with the RUL information, a more efficient maintenance strategies can now be implemented. And this is commonly known to us as the predictive maintenance strategy. You know, and for those who are not familiar, the predictive maintenance concept is all about providing engineers just exactly, or an estimated, maybe not exactly, but an estimated of how much life an asset has left. So he or she can schedule maintenance and replacement of that asset at the most optimal time, basically performing maintenance only when you need to and not any earlier or later. And oftentimes this as needed approach allows someone to do maintenance less frequently than the time schedule approach, which is the commonly used approach. This means you can maximize the utilization of that piece of asset, take advantage of its full operating life, and most likely reduce maintenance costs. So now that we have done all the analytics, the APM software have generated a bunch of insights. The next step is the visualization and the reporting of that insights. So information dashboards in an APM system are a very important element in this solution. Fundamentally, these dashboards have to insightfully provide you the information and present the information clearly so that you know what to do with the information and take proper action. In this slide, we are showing two different types of dashboards from our APM system. The ones with the dark background on the left are what we call summary dashboards. They show more the big picture KPI type information. The dashboard on the right with the white background, they focus more on individual assets like detailed performance of a motor, for example. A simpler way to think about this is that the one on the left would be for a person, say in supervisory role, where they may care more about the summary information on the overall system. The dashboards on the right would be more for domain experts who may need actually detailed information to track the operation and to troubleshoot an issue. And obviously, to go from one type of dashboard to the other is nothing more than a couple clicks, so that any type of information is easily accessed within the APM system. So the fourth element in the APM system that I mentioned before is the workflow automation. And let's take a quick look at this last attribute here. So the ultimate goal of an APM system is not only to tell you that something is wrong or there will be a problem soon, but to also help simplify the process to fixing the problem. On this slide, we are showing the closed loop workflow on how an APM system operates. So if you look at where the assets are, starting from that, the system takes in streaming data, takes in the streaming data, monitoring the assets, and when it detects an issue, real-time notification are sent. Now we are kind of on the top of the circle here. And from there, an engineer can look at the analytic results, which is kind of like the right side, right-hand upper corner there. Take a look at the result through the multiple dashboards, analyze the insights, and then from within the APM system, which is the bottom right there, an engineer could schedule work orders to remedy the problem, right? Our APM solution has an embedded work order system that allows engineer to take basically the whole monitoring to scheduling and work order process right within the platform. And if you're at a facility where you already have an established CMMS system, for example, or EAM system, we can also integrate our APM system with the CMMS system as well to allow a more closed loop operation to integrating with your third-party system. And so that is kind of, an APM system in a nutshell. Obviously, there are a lot more features and functions that we can go over, but I believe those four elements give you a good idea of what an APM system is consisted of. And then for the last part of my presentation, I just wanted to highlight a few use cases, actually 4 specifically, to give you an idea on how some manufacturing are using our APM solution. So the first use case here is in automotive. The APM system is monitoring one of the material transfer robot arm. And for this application, a 3-axis vibration sensor is mounted on the joint of the robot arm. The parameters we're using to monitor this application are the raw vibration data, the 3-axis vibration data, and derivatives from these vibration data. So I believe for this specific application, there were up to 70 parameters or somewhere around 70 parameters that we are monitoring. And all these parameters are summed up into its asset health index. And the chart you see on this slide is the asset health index chart. And obviously the asset health index reflects the health of the specific joint. So looking at the chart a little bit closer, you're seeing in the chart basically how an asset health index is commonly used. On the left, you can see that a relatively flat line showing that the joint is operating normally. However, as time passes, the asset health index begins to trend up and slowly reaching the alarm threshold, which basically the line on the top there. This is an indication that the vibration signal are changing and the health of the joint is degrading. And in this case, the engineer, after seeing the uptrend, analyzed the problem and confirmed that maintenance is indeed required for the reducer in the joint. And as you can see, kind of towards the right side of the chart there, after maintenance was performed, the asset health index returns back to normal, kind of flatline operations at the end there. So this is a very common way for someone to actually use the asset health index, and this is an example of it in automotive. Let me move to the second example. In this second example, I'm highlighting a feature that I didn't touch on earlier. In this specific use case, the APM system is monitoring vacuum pumps. As I mentioned, vacuum pumps as a critical asset as factory support tools. There are a total of 5 parameters that are monitoring per pump, consisting of things like vibration, pressure, and power. Again, these parameters are summarized into an asset health index for each of the pumps. So let's look at the charts themselves. On the chart to the left, you can see that the APM system detected a performance trend. The asset health index, as you can see on this chart, is trending up there, indicating that the pump could result in a device failure if we just let it run as usual. A notification was sent to the engineer in this case, but not only to notify the engineer that, hey, something is trending up and something might be going wrong, but also to give him some clues on the source of the problem. So right above the chart, you see another chart, a spider web chart, that shows which parameters are contributing to, the health score, right? The uptrend. And with this information, especially someone with domain knowledge on the asset, like the equipment engineer, he or she can then quickly identify the issue. And in this case, the engineer that are responsible for these vacuum pumps identified that clogging in one of the pipes was the issue. So the engineer validated the alarm, and then he took a step further by tagging this alarm in an APM system. Now, whenever the system detects an issue similar to this failure profile, it would automatically know that and classify it, the problem to be clogging. So that is all part of the benefit of using AI or machine learning in an application, the ability to learn and the ability to provide knowledge after the learning. Okay, in this next example, I have an application in the logistics industry. In logistics applications where there are usually miles and miles of conveyors, conveyor motors are important assets. In this application, in addition to monitoring the health of the motors themselves, say by using vibration sensors, the customer was also concerned with the power source that are feeding these three-phase motors. When there's poor quality three-phase power feeding motors, over time that leads to overheating of the motor winding, and the motor could fail prematurely. So that's why the customer was very concerned that the power source must be monitored as well. So knowing the quality of the power is just as important sometimes as knowing the health of the monitor. The health of the motors. In this case, we are monitoring the three-phase current going into the motor. So basically the asset health score, the chart that you see here, is a reflection of the quality of the power source. So let's take a look at the chart itself. As you can see on the left side, unbalanced events were not so frequent. As you can see on the chart there, the three-phase power is very stable and very balanced. So in the asset health score chart, you don't see the noise that you see on the right side of the chart. The random spikes that you see on the right side are basically the results of when the three-phase power become unbalanced. Now, by using this asset health index, it is providing you this story that the power quality is deteriorating, and that some attention is needed. So in my last use case example, what we have is an application in the wastewater industry. An APM system is set up to monitor the system at a muni water facility. The diagram on the left there kind of shows you what the system looks like at a high level and the type of parameters that we are collecting to analyze. Again, like the last example, in addition to monitoring the asset itself, in this case, the pump, we are also monitoring other vital parameters from the system, including system pressure, flow, inverter power, etc. In this case, the asset health index, now we are moving down to the chart in the bottom there. The asset health index indicating that at 3:10 p.m., there was an abrupt change in the performance of the system. In addition to the alarm, due to this abrupt change, the solution also gave the engineer two main causes for this change, namely the system water pressure. Now we're on the right side, the two charts on the right, the system water pressure as well as the inverter power. As you can see on the right side, right at around 3:10 p.m., both of these parameters also abruptly changed. With this information, the engineer was able to quickly identify that there was a leak causing the pressure to drop in the system. And that is why the inverter was trying to max out its power output to try to drive the pump harder to maintain the pressure. Again, this is an example of how the asset health index is applied beyond an asset, but on a system level, similar to what we show in example number 3 as well. So I hope through these 4 use cases, you get an idea on how an APM system can help you monitor your asset and to help you reduce failure events. And with that, I'm going to pass the mic back to Stu to sum up our presentation for today. Stu?
Great. Thanks, Joe. Thanks for the insight there. Let me just move to the last slide here. Oh, there we go. Anyway, before we take some questions, I'd like to thank everybody for their time today. There's a couple of takeaways I'd like you to remember. Number one, we've been talking to customers over the last couple of years, and particularly in oil and gas and some of the industrial sectors, they've asked us make it easy, and so we have tried to make it easy. So the integration, whether it's a legacy system or a new system, we think is quite seamless. And we actually put our money where our mouth is, or put our data where our mouth is, and that is, we will, we offer a free POC program where you have the ability to actually demo, test drive the Grandview APM. All we need is some data, and we'll work with you to show you what the potential is with the Grandview within your asset. So there's a couple of resources there, I think, and encourage you to take advantage of and see if this is a possible solution as part of your digital transformation strategy. So with that, I'd like to again say thank you, and then hand it back to Gary for questions.
All right. Thank you so much, gentlemen. That was all fantastic information. Now our presenters are going to answer some questions from the audience. So if you do have questions for Stuart and Joe, please type them in the Ask a Question box on your screen. We'll get to as many questions as time allows. Any questions that we don't get to today will be posted online with the archive version of this webcast. And remember, to download a certificate of completion and a copy of the presentation, use the Event Resources tab on the left side of your screen. All right, gentlemen, if you guys are ready, we'll hop right into the Q&A. I'll throw these out here, and whoever is more comfortable answering, feel free to answer. Let's start with, how much historical data do you need to establish the training models? And what happens if you have zero historical data?
Joe? You're muted, Joe.
Sorry, guys. I was muted.
No problem.
Yeah, great question. Typically, we recommend 2 to 6 months of data to establish the preliminary model. Obviously, the more data, the better, and that is kind of our model to the customers. The more data, the better. 2 to 6 is the minimum, and if you don't have any data, and we run into a lot of situations where the customer just never collected data before on these assets. What would have to happen is we would run the system with new sensors and for a month or two, and collect the data before building the model for detection. So there would be a data learning period that is going to start after you deploy the system.
Got it. Simple question here. Is the APM system cloud or on-premise?
Our APM system can both be cloud and on-premise. We have customers using both infrastructure strategies.
Perfect. How do you support customers that have no sensors in the equipment?
I think we get. I'll hit that one up, Joe. So, I think I touched on that in the early part of the conversation or the presentation, but we come across, I think, roughly 25% of the time, customers that have zero sensors. We work with a sensor partner, and we've got actually a couple spread across the nation and in Europe, and so we work with our partners to sensorize that equipment. It's not a showstopper. It's definitely overcomable. We tend to see that in the smaller number of customers with small number of parameters, but it's definitely overcomable.
Got it. How long does it take to deploy and install?
Joe, you want to head out?
Yeah, great question. So it depends on several factors. Again, whether data is already available or not. I mean, if data is already available and historical data is available, that would significantly kind of short circuit the deployment process. In that case, we would probably spend a week at day. Well, obviously, we would have to work closely with the customers themselves, but we typically spend a week in data integration and then another week for modeling with historical data. And if the system is deployed in cloud, that also speed up the process as well versus, if you have to install it in servers on an on-premise situation. So say best scenario is you have data, you have historical data, and it is in the cloud. The system can be deployed within a couple, 3 weeks. Now, if you don't have historical data and we have to run a month or two of training, obviously that month or two is part of the deployment process. And then we do the modeling. And then, depending on whether or not, it is an on-premise situation, the worst case could be, a few months. So it could be from a few weeks to a few months, depending on the situation.
Got it. That makes sense. Is your solution industry specific?
No, I can address that. So it's not, first of all, it's not industry specific. We have multiple domains that we work within, motor, pumps, fans across industrial, semiconductors, electronics, logistics, infrastructure, multiple different applications. So no, it's not industry specific.
Got it. Next question. Are clients using your software to replace existing software or to supplement already existing operation software generally?
Another good question. As I mentioned before, a lot of facilities already have some sort of, say, HMI software in monitoring their systems and whatnot. Actually, the last use case I used, the Muni Water, I wish I had the picture to show you. We actually took a picture at their control room, and they had an HMI screen right next to our Grandview APM screen. So some customers do have, multiple applications in monitoring their systems. Now, when you talk about the typical HMI visualization, you're looking at, a higher level plan-wide sort of monitoring, and typically is more current status and whatnot. With our APM system, you are focusing in on your critical assets only, and in addition to current status, we also give insights like predictive information as well. So the use case is a little bit different, but customers typically run both in their applications, and we are working towards the ability of integrating our insights into HMI software as well. So this gives the customer the ability to maybe focusing in on one screen, but with all the information they need.
Got it. Joe, I'm going to direct this question to you because it was something you mentioned in the presentation. So you mentioned a number of problems this software can resolve. Are there a few that are most often addressed?
Yeah, so from our experience, there's a lot of factory support and facility applications that have long been neglected for years and years in manufacturing, that facility managers and maintenance managers are becoming more interested in monitoring. This is HVAC system, scrubbers, chillers, all the support tools, as I mentioned before, like vacuum pumps, subfloor tools and whatnot. Those are, at least in our experience, some of the very common applications that we are facing.
Got it. Stuart, I'm going to send this one your direction. Slide showed that many areas have a long way to go on adoption rate and operational efficiency as the main driver. Are there other key areas helping companies with implementation?
Other key areas. I would say that a lot of companies are now implementing or making official like digital transformation as part of the overall business strategy. So I think we've started to see that, particularly in pharmaceutical and chemicals. I think others are still a little bit ways behind, but they're now recognizing that data. So I'd say really having a commitment to it and making it part of the overall strategy is one thing. I think getting IT on the same boat as the OT guys, working together. I think that's key, and really understanding what is out there and paying a little bit of attention to it. But it's definitely picked up the last year and a half, for sure.
Sure. Yeah. Bridging that IT-OT divide is always a little bit of a challenge.
Yeah.
Joe, we'll go back to you on this. How much data is required to get started, and to monitor a few water pumps, what does it cost to get started?
Well, I'm not going to talk about costs on this this webinar, but I can kind of mention the how to get started piece of it. And obviously, if we want to talk more about costs, we can certainly talk about it offline. But to get started, typically it all depends on the type of assets that you're monitoring. As I mentioned earlier, there are simpler assets like a simple motor where you may only have a vibration sensor on it. In that case, it is one or two or maybe three parameters per that one asset. But then there are more complex assets where you can have upwards of 10 to 15 is the common that we see on complex devices parameters per asset. And to get started, our recommendation, and I think this is a pretty common market recommendation as well, is when you start an APM system, try to deploy it in a smaller scale first. Make sure you understand the system, the kind of ROI and benefits that you can get from it before scaling out Plan Y. And I think this is a pretty common practice, and I believe a lot of our customers are doing that as well with us. So again, the system size starts small, depending on the type of asset that you have. It could be you're talking 3 to 10 parameters in general per asset, and if you're saying starting a system with just maybe 10 or 50 parameters, you're talking about really just a 500 parameter system, which is relatively small for an AI driven monitoring software, right? So and the cost of it would really be minimal.
Got it. When you talk to potential customers, what's still inhibiting adoption of this technology?
Yeah, as I mentioned before, a lot of the customers that we are talking to had never gathered data before in their assets. So the shock comes when they realize that they have to maybe retrofit a bunch of sensors into their devices, and that work and that hardware cost sometimes could spook a customer in the initial process, but a lot of our customers understand that once they go over that little hump there, the world is their oyster, right? Once we have data, we can do all kinds of stuff and prevent all kinds of problems for them. So, but typically the inhibitor is usually usually applies to the customers that hasn't the customers that haven't historically collect data before. So to get that going sometimes is a little bit of an obstacle. Yeah.
But to add to Joe's point, Gary, a lot of the customers we see, and most industries, I'd say 75% of it, we piggyback into existing sensors or data collection capabilities. I'd say about 25% of the time, like Joe said, it's maybe smaller, older manufacturing facilities that are not sensorized and don't really understand the process, and are a little bit spooked, as he says, regarding the cost to sensorize and get yourself in a position where we can actually collect and detect and manage the data. So that's definitely the challenge for a small percentage.
Makes sense. Stuart, I'm going to go back to you with this one. Can you show the 70 parameters, and is that large of a parameter list typical to your systems?
So we're actually all over the map on this. So we've got some customers where, we've got, thousands of pumps, and on average about maybe 10 parameters per pump. So what is that? About 10,000 parameters. We've got other customers where you've got simply a small facility, maybe a couple hundred parameters. So it really varies. Like I said, the beauty of the system, and this is where we listen to the customers, is the scalability of the system. We can integrate pretty much piggyback, like I said, into most existing sensor networks, and we can connect to and access that data. Once we've got that, then the analytics engine can go to work quite easily. So like I said, large or small, we can scale. So hope that addresses your question.
Sure, thank you. Joe, we'll go back to you. Can you comment on the methods of evaluating the quality of data and related metrics?
Yeah. So, as I mentioned, the data can come from any source, and as part of the deployment process, we actually sit down with the customer and usually their IT group as well, and that is when we really talk through what data is necessary, where is it coming from, what is the infrastructure look like? Are we going to be able to rely on this data being connected 24/7? And actually, in our software itself, we do have a data quality check. So when, say, a disconnection happens or when interruption occurs, our system would flag that and tell the system, tell the engineer, so that they can assess whether the insight is based on good data or not.
Got it. Is it just using time series data or other types of data as well?
Yeah, we use mainly time series data because it is a kind of a chronological real-time analysis. But we do also bring in event data as well, so that we know, say, for example, if a maintenance event had happened, we want to know that, right? So event data and time series data typically, yes.
Yeah. Is software development required? Data science expertise?
Great question. So no, typically there's no software development. Our system is kind of turnkey-ish. And when I say turnkey-ish, because there's a data integration process where we may have to do something to get the data from a place. Yeah. So that part of it may require some customization in connectivity, but the analytics piece itself is turnkey. And do you need a data science to run our software? The answer is no. Typically, our data science team will help with the modeling process before the deployment. And once the model is established, in operating the software, there's no data science knowledge required.
Perfect. We are amazingly already getting to the very end of this. I think we're going to take one more question here, and then we'll wrap up. So the last question: is this solution available today, and how can users test Grandview APM?
All right. I would say yes. First answer is yes, and like I mentioned in the wrap up, we actually have a free POC program where you can actually go on to www.identix.com, click the free POC button, and then just fill in your information. And that'll get us connected with you. We get some data, and we can basically test drive the APM with you quite easily and quite quickly.
Excellent. Everybody, thank you so much for all the great questions. And thank you again to our fantastic speakers, Stuart Chalmers and Joe Lee, for sharing their time and expertise.
Great. Thank you.
I'd also like to extend a special thanks to Identix for sponsoring today's event. Now that we are just about done here, we're not quite done. We still want to hear how we did. An exit survey is going to pop up on your screen as soon as this webcast ends. Please take a moment to complete it because we use this information to improve our future webcasts. Finally, on behalf of Control Engineering and Identix, I'd like to thank you for attending. This concludes our webcast. Thank you, everyone. Goodbye.
Thank you.
Thank you.